Hi geometry students, this is Ms. Hefty here. We're working on our segment proofs today, and in a previous lesson we worked on filling in blanks and trying to follow patterns of proofs with some assistance by having some of that information there. Today we're going to tackle proofs, two-column proofs, filling in both the statements and the reasons. And so I thought I'd briefly review the process of writing proofs. The first thing you do when you're writing a proof is you write your givens down, and if you don't have a picture drawn, you should draw a picture. And then from there, you should use your deductive reasoning to look for, okay, what can I say next? And through that process, I'm going to be using some reasons. And so let's look over here at what I have for our reasons. When you write things down, you have to explain why you're doing what you're doing. Those are your reasons. Well, when you write your first statement down, you were given it. So givens are going to go in the reason column. You're going to use postulates, like your angle addition postulate and your segment addition postulate. That's going to introduce information to use in the proof. You're going to use your definition. So if you're given complementary, then you can say they add up to 90 degrees by the definition of complementary. And then the last thing is theorems. We are going to use theorems. We don't have any theorems at this point, but we're going to be writing proofs. Those are called theorems, and then those theorems are going to be used as shortcuts for proofs later on during the year. So let's take a look at our first proof. We're given line segment with points STP, and we need to prove SP equals ST plus TE plus EP. Now, at this point, some kids might be saying, well, that's just segment addition postulate. Segment addition postulate says adding two pieces together to equal the whole entire line. This one has three, so we do have to write a proof for this. Remember at the beginning of this chapter, we had if-then statements. The given is really the if part of the if-then statement. If I have a line segment with points STP, then is the prove, then prove SP equals ST plus TE plus EP. So the prove is the then of the if-then statement. So when you go about doing a proof, the first thing you should do is take your givens and write them down. That would be in step number 1. So that's what I did here. Line segments with point STEP. How did I know? How come I wrote that down? Because I was given it. The next thing I would do is I would go down to the bottom, and I usually will tell you how many steps it took me to write it. It took me 4 steps to write this one. So I would go down a ways and I would write, okay, what do I want to say at the end? I want to say the proof part, SP equals ST plus TE plus EP. Do not write prove. Prove is not a reason. All right, now let's go back up to the top, and we have to move down the paper now to arrive at our conclusion, which is SP equals TE plus EP plus EP. If you want to have SP at the end of the proof, then you need to introduce it here. So I'm going to introduce my SP in this line. When you introduce a proof, you look at the picture. Here's my picture. There's SP. I need to have ST at the end there. So I'm going to take ST plus TP to equal SP. I'm using my segment addition postulate. Use your segment addition postulate to introduce that line segment. And that's my segment addition postulate. Now let's look at the last statement. SP, SP equals ST, ST. Okay, so at this point in my third step, I need to introduce the TE and the EP so that I can use that in number 4. So when I look at the picture, here's TE and EP. They equal this whole line TP. So once again, I'm going to use my segment addition postulate to introduce those. TP is TE plus EP. And I'm using my segment addition postulate. Okay, now, looking at the fourth step, let me get my highlighted stuff out of there. Okay. You might be going and looking back here and saying, did step 4 come from step 3? It actually lines up, people, with the previous one. It lines up here with 2. See how you have SP and SP equals ST equals ST? The TP is gone and the TE and the EP is in its place. It can take its place because they're equal. So when something takes your place on the basketball court, that's a substitution. Same thing in mathematics. All right, let's move on to our next proof. You're given SA congruent to ND, and you're asked to prove SN congruent to A, this should be AD. So let's go ahead and start. This time this one has 7 steps. You're going to take your given and write it down as your first statement, and your reason you wrote it down is because you're given it. You're going to take your proof and you're going to go all the way to the bottom, 7 spots down, and you're going to write your proof. Again, this is not prove here. Prove is not a reason. Do not be writing prove there. Nobody's doing that on the quiz. All right, let's go back up to the top. The difference between this proof and the previous proof is this one has congruent symbols. When you have congruent symbols, you need to change to equals before substituting. Substitutions are done with equal signs. So the first thing I'm going to do after I write my givens, the second step, I'm going to write SA equals ND. And the reason I'm doing that is because the definition of congruent says I can change it to equals. That's what congruent means. And I know the book views like congruent segments, definition of congruent segments, definition of congruent angles, but definition of congruent is good for me. All right, now, when I look down here at the bottom, if all the way through here I'm going to have equal signs, then the one above this has to have an equal sign. So I'm doing a little bit of working backwards in this proof, people. So I'm going to write SN equals, I do have AD. I did type this correctly, guys, AD. Okay, now, when I go back up to number 2, if at the end I'm going to talk about SN and AD, I need to introduce those. Remember that? So I'm going to introduce, in step number 3, this is where I'm doing my introducing. I need to introduce SN. And I need to introduce AD. To introduce SN, look at the picture. What 2 pieces are adding to equal SN? I got SA and AN. Now I need to, by the way, I put these together on the same line because I'm doing segment addition postulate. That's how I do that. So you can kind of follow along. That's how I arrive at my steps. If you're going to count that as 2 steps, you're going to end up with 8 steps here, guys. So here's AD. What pieces add together to get AD? AN plus ND. And so for step number 3, what I did is I took the whole segment equals 2 pieces added together. So that is the segment addition postulate. Okay, now at this point, I'm looking at it and I'm going, okay, I need SN at the end, I need SN on the left, and I need AD on the right. Here's AD on the right. And so I'm thinking, okay, this stuff here really needs to go right here. And this stuff here really needs to go right there. And people will think that that's a substitution, but you don't have SN anywhere up earlier in the proof, and you don't have AD up anywhere earlier in the proof. So you cannot do a substitution. So if you were working ahead and thought, I'm going to write this stuff right here, and I'm going to write this stuff right there, that's incorrect. Let's take a look here. Let's go down to the bottom. I'm looking down here at SN and AD. If I want to have SN over here on the left, what needs to be above so I can have SN be on the left? This stuff right here actually needs to go right here. If I want to write SN there, this needs to be right here to go there. Then AD, if I want to have AD on the right, then AN and ND needs to be right here. Now, I think I have too many lines here. 1, 2, 3, 4, 5, 6, 7, 8. Sure enough, I have 8 lines. So I really don't need one of these lines. I'm going to white mine out. You don't have white out. Maybe you want to just draw a squiggly line through it. But I have too many lines. Okay, so I just need a middle line. Do you see here? Here's SA, and there's SA. Here's ND, and there's ND. AN and AN are not anywhere earlier in the proof. AN equals AN needs to be written right there. Now, what is that called when both sides remain the same? They look the same. That's called the reflexive property. I don't know, some students get reflexive and symmetric confused. Symmetric is the switching around property. Reflexive, I think of it as remaining the same. AN equals AN. So that's the reflexive property. All right, now what happened here is I'm adding this and this together to get right here. Do you guys see how that is? Here's SA on the left, here's AN on the left, and I've added them together is what I've done. Then here's ND on the right, here's AN on the right, and I'm adding them together and I'm writing them on the right. So this is different than the last one. So I've just added those together. So that's the addition property or the add property. From here, here's SA and AN. I'm putting SN in its spot. In number 3, SA and AN are equal. So that's called a substitution. And if you want to check the other one out as well, here's AN and ND. Here's AN and ND. It's the same thing as AD. So I've substituted. And then from, this is 1, let's see, 1, 2, 3, this is 4, this is 5, here's 6. From 6 to 7, you went from equals to congruent. So that would be definition of congruent. So I'm going to stop this video. I do have one more proof to do, and so I'm going to have to start a new video lesson. So you need to watch part 2 of this. So I'll see you in a couple minutes, guys.